Oh, yeah. Um, yeah, the chapter 6 worksheet 2s do, I'm not collecting worksheet 1. Worksheet 2 and worksheet 3. Oh, I guess they're,
Is 3 due Thursday as well?
3 is not due Thursday,
Oh.
however, um, let's download it. However, it might be helpful for you to print it out because it's 2 pages and we've already covered what you could, 1 through 6. They're very easy. 1 through 6 are exactly what we just did on worksheet 3. And that's why I didn't assign worksheet 1, because worksheet 1 was all stuff like that. I should say, okay. Yeah. So you can print that off, and then we're going to cover how to do 7, 8, and 9 now.
Okay, so I could technically have it done by Thursday.
You could have half of it at least done. I'm not sure if we're going to get to this,
Oh, okay.
but we might.
Yeah, I thought I recognized a calculus principle there whenever you said area under the curve.
Right, right, exactly.
So how would you set it up as a, what would you use as the function?
I don't know. That's the thing, Bart. I don't know what the function is.
Yeah, that's the thing. Because like, I assume the operator would be X. You would use
I imagine
X
you would
dx,
have
but-
to look it up on the internet or
Yeah,
something.
I'm curious as to what the actual function would be that you would integrate.
All right, so this is inverse normal probability distribution. And we're going to use this when we are given areas. See, the previous thing, we were told our values of z and asked to find areas. When we're given areas, you know, in areas are percents or probabilities. And are trying to find the x or z, the numbers on the horizontal axis. So we will use inverse norm on the calculator. Second variables, which is distributions, inverse norm. And then the calculator does require that you put the area to the left of the z-score that you're trying to find. And then it will give you it as a and you need to enter the area as a decimal. The area has to be a decimal. Here's some examples. Find the indicated z-score. So we know this is z on the horizontal axis because it's going from -3 to 3. And it does say z-score. So z equals inverse norm of the area to the left, written as a decimal. So in this problem, we're given the area to the left is 0.1075. So if we just put that in our calculator, we're going to get z. Second, distributions, inverse norm is number 3, 0.1075. And we are going to round z to 2 places. We rounded areas to 4 decimal places. Z will be rounded to 2. Round your answer to 2 because it's z. And that is negative 1.24. And does it make sense to our picture? Our picture is actually pretty accurate. Yes, this is negative 1.24. So we're given an area to the left. We want z. We're told it's a standard normal curve. You use inverse norm of the area to the left and you get your z. Because it's z, we're going to round to 2 places. Don't get your z's confused with areas. All right? Example 2. Now we're given that the area to the right, we're trying to find this z right here. And the area to the right is 5.02%. So you need to change that to decimal, move the decimal place over 2 places. So the area to the right is 0.0582. Well, the calculator requires the area to the left. What's the area to the left? Because the whole area is 1, we're going to subtract 1 minus 0.0582. You have to put in the area to the left. The calculator requires that. So 1 minus 0.0582 is 0.9418. So now this z is inverse norm of 0.9418. You put that in the calculator. Remember, we keep 4 places for area. Second distribution, inverse norm, 0.9418. And we get 1.57. And you want to label it with z equals. Don't tell me that it's 1.5701 because you think it's an area. Okay, it's a z. By the way, if we're talking about the z-axis, if we're to the right of the mean, z is always positive. If we're to the left of the mean, z is always negative. So we can't get negative areas, but we can get negative z-scores. All right, and let's do the area between the central area. Let's find the 2 z's around it. So we're going to find a negative z and a positive z. This is a central area. Assume I'm giving you a central area. Here's the picture. The central area is 0.7814. So find the area in the 2 tails. To find that, so the area in the 2 tails is 1 minus 0.7814. So we're going to subtract that. 1 minus 0.7814. 0.2186. And then to find the area in 1 tail, we're going to take that and divide it by 2. So divide that by 2 because it's symmetrical. And we get 0.1093. So we got 0.1093 here and 0.1093 here. Now we can find negative z. Negative z is inverse norm of the area to the left of it is 0.1093. Put that in your calculator. Second distribution, inverse norm, 0.1093. And you get negative 1.23. Well, because this is symmetrical, our positive z is going to be the absolute value of negative z. The absolute value of negative 1.23 is 1.23. So we get 2 z-scores. The area, the central area between those 2 z-scores is 0.7814. Any questions on that? You have to do that on your homework. Okay, does that make sense? Sorry. let's see. Did you show that? Okay. Just mark down. Keep track of who's staying. Okay. All right. So the central area, you find the area and the two tails, subtract from 1 and divide by 2, and you can use symmetry. So then, and this is just like your homework, so except different numbers. So find the z-score such that 38% of the area lies to the left of the z-score. So now it's a word problem. It says 38% of the area lies to the left of the z-score. So we're finding a z-score, so draw our standard normal curve. When we mark it 0, make about 3 marks going each way. And z always looks like this. We're going to find the z-score so that 38% of the area lies to the left. Now here it might help. I'm not sure where to put this line, and you can use the empirical rule to figure it out. You know, you got 0.34 in this, oh. Let's see, you got so from here back, you know, this is 68%. So if we got 100% minus the 68% is 32%, and half of that for the two tails is 16. So we got 16% here. So 38% is going to have to lie between -1 and 0 because 50% is there. So I was just trying to figure out where to put this line, and it's a 38% or 0.38. It's giving us an area and it's asking us for a z-score. And then they gave us an area to the left. That's why we started on the left. And I was just trying to figure out, using the empirical rule, that 100% of the data between -infinity, infinity, 68% here, that leaves 32 for the two tails, 16%. So we had to be a little further over. So z equals inverse norm of the area to the left is 0.38. Don't have to subtract from 1 because we're given the area to the left. You're required to put in the area to the left. Okay. All right. Second distribution, inverse norm, 0.38. And I'm thinking when I first see that negative number, oh no, I got a negative area. No, that's z. Going around in 2 places. This is the z-score. It's a number on the horizontal axis, and it makes sense that it's between 0 and -1. So it should be negative. We're only going to round it to 2 places, negative 0.31. All right. Then, any questions? And this is all being recorded. So, the next one, let's find the z-score such that 15% of the area, it's giving us an area, lies to the right of the z-score. Okay, so we draw our picture, and you're required to draw the picture, unless it's already drew it for you, as part of your grade on the assignment. Draw the picture. You can take the notes and trace it if you want. 0, you make about 3 marks each way. Z, it's the standard normal curve because it's talking about Z. Alright, we want so that 15% of the area lies to the right. So 15% is going to be between 1 and 2 because of what I did up here, figuring out that 16% would be from 1 on out. So this is our Z that we're looking for, and this is, we shade the area to the right. That is 0.15. But in order to find Z, inverse norm, we have to put an area to the left in as a decimal. So we have to subtract from 1. 1 minus 0.15 is 0.85, or just do it on your calculator. Inverse norm of 0.85. And we should get a positive number for Z, and it should be close to 1. Inverse norm of 0.85. It does require a decimal between 0 and 1 as the area. It'll give you an error if you put in 2 or 10 or something like that. And you get Z is 1.04 to 2 places. And that makes sense. All right, any questions? Making sense? All right, and then we gotta assume this is, when I tell you that 28% lies between two z-scores, it's the central area. Always assume it's the central area unless I tell otherwise. So it's going to be a central area. So we're going to draw a picture of that. Zero, 1, 2, 3. 1 minus. Okay. Now, we got 28% is a central area. We know that 68% is between -1 and 1. So 28% must be somewhere in here. It's just going to be narrower. This is going to be our 28%. So you want to find the two z-scores, minus z and positive z. So you have to find the area to the left of the negative z. So again, you find the area in the two tails. Is 1 minus 0.28 or 0.72. Subtract that on your calculator if you need to. And then the area in one tail is 0.72 divided by 2, 0.36. So this should be 0.36, this should be 0.36. And if you add up 0.36 plus 0.36 plus 0.28, you better get 100 or 1, 100% or 1. And you do, 72, yeah, you get a 1. The whole area under the curve equals 1. So we can find negative z now. Negative z is inverse norm of the area to the left of the negative z, 0.36. And it should be negative, and it should be between 0 and 1. So, second distribution, inverse norm, 0.36. And remember, this is z, so you're going to round to 2 places. It's negative 0.36. Wow. Negative 0.36. That's not an area. That's the number right there. It's negative 0.36 here. Well, what's this number going to be then? Z will be 0.36. It's going to be the absolute value of that. It's symmetrical. Z is negative on the left and positive on the right. And it just ended up to be, it's going to be rare that this happens, that you have the area to the left ends up to be equal to the z-score. That's just happened. It doesn't, it's not going to happen often. It didn't happen on the last question. This is probably the only one that it happens on. All right, any questions? All right. So we're going to keep going a little bit longer. So when we're given data that's normally distributed, so, okay, so we've covered the standard normal distribution. We found areas under the standard normal curve using normal CDF, and we found z-scores given an area using inverse norm. Now, if we are given data, we usually are not given z-scores. If the data is normally distributed, but not the standard normal distribution, we will need to convert to a standard normal distribution. You do need to know how to convert to a standard normal distribution. We convert all x values are converted to z-scores or z-values by the formula z equals x minus mu over sigma. Okay? And you do need parentheses here. Now we have covered enough for you to do worksheet 2 and for you to do the first page of worksheet 3. Worksheet 2 due Thursday, worksheet 3 due Tuesday. And don't forget to do the test on. Okay? But we're going to go ahead and cover a little more and then we'll stop. Okay? This is how to convert. I don't require that you convert. On finding areas under an X curve, I like to use a shortcut on the calculator. But I do, you do need to know how to convert from an X value to a z-score. So I have a problem on the test where an ACT score was this, with a mean of this, standard deviation of this, and the SAT score was another number with the mean and standard deviations given. Find the z-scores and tell me which was better. Yes?
So the worksheet that's due Thursday is this page, or not this page, but like this page?
Yes, the worksheet that's due Thursday is just like the last 2 pages we covered. This one and the worksheet that's due Thursday is just like these 2 pages.
Okay, thank you.
Okay? The section, chapter, worksheet number 3 is like, has the first 6 problems are like this page. and then the next three are like the page we just covered. That makes sense. So you can actually, so anyway, the Z-score, so it is a skill you'll need to be able to do, but I do give you the shortcut. So, but here's how to convert. Okay, we're going to convert. If it tells you, if you're given a number and it has units, that means it's an X, and that's called a raw score. But the amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes, so mu is 25, and a standard deviation of 2 minutes. Sigma is 2 minutes. They have to be in the same units, the mean and the standard deviation. But I don't do something mean like tell you the mean is 25 minutes and the standard deviation is 30 seconds. I don't do that, but but I could, okay. But it does have to be in the same units. So we're going to convert 21 minutes. This is our X, is 21, to a Z-score. We use this formula, X minus mu over sigma. Why don't we use inverse norm? Inverse norm, we found Z-scores of that, is because of what we're given. In this problem, we are given X and the mean and standard deviation, everything that you need for this formula. We only use inverse norm when we're given an area. So that's why we're not using inverse norm. Just plug in 21 minus 25 and divide by 2 is negative 4 divided by 2 is negative 2. And if you do it in your calculator, you will need to use parentheses because the calculator doesn't do fraction bars. And convert, so that's the answer. Our Z-score is negative 2. Convert 29.7 minutes, so X is 29.7 to a Z-score. So Z is X minus mu over sigma is 29.7 minus 25 divided by 2. That's 4.7 divided by 2, or 2.35. We can check by drawing the picture. So I'm going to draw a picture of the normal curve. We'll draw the normal curve with our pizza delivery stuff. So we have a mean of 25 and a standard deviation of 2. So we add 2 going up, and we subtract 2 going down, 23, 21, 19, and this is our X. And we could draw our Z underneath it. If we just put our Z here, I'm squeezing it in here. 0 will be here, 1, 2, 3, minus 1, minus 2, minus 3. So do our answers make sense? When we converted 21 to a Z-score, we got negative 2. That makes sense. When we converted 29.7, that's a little less than halfway between those, we got 2.35. That made sense also. Okay, so that's how you convert. And so we'll just finish this page up and quit. So here's an example of an actual application problem, and I am going to give you the calculator shortcut. So let's write this down. You want to use the calculator shortcut. The calculator shortcut for this problem is probability that X is between or less than or greater than is normal CDF. I'm going to just put NCDF. The lower limit of X, the upper limit of X, the mean of X, and the standard deviation of X. So you can use it. It just depends on the problem whether you can use negative. You know, if we're doing, sometimes I'll use negative 1,000 for less than, and positive 1,000 for greater than. But it has to depend on the problem. If it's miles that a tire, say a tire lasts 25,000 miles and your units are in thousands, you can't use 1,000 and negative 1,000 for positive infinity. You can still use negative 1,000 for negative infinity because you're way down in the negatives. But okay, so this is the shortcut. So here's the problem. It says when we are asked for a probability, we're going to use the normal CDF. Remember, a probability is an area under the curve. We find areas with normal CDF. So it says, find the probability that the monkey's weight is less than 13 pounds. So here's the notation, probability X less than 13. We need to draw the picture. The probability notation, drawing the normal curve. If we're going to use the shortcut, we're not going to write Z down here. We're going to put in the mean of the monkey's weight is 15 and the standard deviation is 3. So we start with 15, we make about 3 marks each way. Okay. Add 3 going up, because we add the standard deviation going up. We subtract 3 going down, 12, 9, 6. Less than 13 is going to be right in here. It's going to be to the left. And remember, we're going to negative infinity, and negative 1,000 is fine for that. So we're going to go from negative 1,000 to 13. So this equals normal CDF negative 1,000 to 13. And then if we're using the shortcut, you cannot leave off the mean and standard deviation. You have to put in the 15, because that's the mean, and the standard deviation was 3. So this is the lower limit of X, this is the upper limit of X, this is the mean of X, and this is the standard deviation. So if you leave the mean and standard deviation off, it assumes you're using the standard normal curve Z, and it'll use a 0 and a 1 there. Okay? So we're going to put that in our calculator. Second distribution, normal CDF, negative 1,000, comma, 13, comma, 15, comma, 3. If you get all of those numbers mixed up, you're going to get the wrong answer. 0.2525. And one of the most common mistakes is to leave off the mean and standard deviation. If I do that, and if I just hit delete, there we go. If I leave off the mean and standard deviation, it thinks it's the standard normal curve, and it gives me an answer of 1. Why is it giving me an answer of 1? Because here's our standard normal curve. There's 3. So if we're going from negative 1,000 to 13, that's virtually the whole curve. That equals 1. That's the Z. So the answer is not 1. if you're getting answers of 0 and 1, and you've shaded less than the whole curve over here when you drew your picture, you're forgetting your mean and standard deviation. You have to put all of them in. Now, you guys that have those scat wizards, you're going to have to be able to, it'll prompt you for the mean and standard deviation too. If you want it to be z, you're going to leave it at 0 and 1. All right? So this is the probability that z is less than 13, and that equals 1. So that we put the wrong thing in the calculator. Let's find the probability that the monkey's weight is between 12 and 17 pounds. Here's our notation, 12 and 17 pounds. And let's just use the same picture because I'm a little bit lazy. We can use the same picture. Here's 12. We'll just use a different color. Here's 17. So we want, it's going to be a little less than 68%. Didn't go up to 18. So that's going to be normal CDF, 12, 17, but then don't forget to put in the mean of x and the standard deviation of x. If you forget those, you will get 0, because between 12 and 17 on the standard normal curve, you're way off to the right. That area is 0 to 4 places. So, normal CDF, 12, 17, 15, 3. And we get 0.5889. And that's the answer. Does it make sense for what we shaded? Yes. It's a little less than, it is less than 0.68. So you should make sure your answer makes sense. And we'll stop there. Do you want me to show you what happens if you leave off the mean and standard deviation? Do you believe me that you'll get 0? Oh, you get 1 times 10 to the minus 33. That's 0. Yeah. If you get crazy answers like that, you're leaving off the mean and standard deviation of x. All right. We're done for today.